The Tea War. A sunny afternoon in the 1920s at the Rothamsted Experimental Station in England. A scientist named Dr. Muriel Bristol declined a cup of tea offered by her colleague, the mathematician Ronald Fisher, claiming she could tell the difference between tea where milk was poured first versus tea where milk was added last. Fisher, the arrogant young scientist, scoffed, insisting it was thermodynamically impossible to taste a difference. Another scientist, William Roach, who later married Bristol, challenged them. Let's test her. He didn't just give her one cup, that would be a 50-50 guess. Instead, he prepared 8 cups, 4 with milk poured first and 4 with tea first. To make the results valid, he introduced randomization. He presented the cups in a random order unknown to Bristol, ensuring her success wouldn't be due to a predictable pattern. This became a cornerstone of experimental design, a field Fisher essentially invented. In this case, we should understand the null hypothesis. This is the default assumption, in this case that Dr. Bristol was just guessing and had no real skill. The p-value, the luck factor. Fisher calculated that if she were truly guessing, there was only a 1 in 70 chance, about 1.4%, that she would get all 8 cups right. Fisher famously proposed a 5% threshold, 0.05, for statistical significance. If the chance of a result occurring by pure luck is less than 5%, we reject the idea that it happened by chance. The result in legacy. Muriel Bristol got every single cup correct. Because the 1.4% probability was well below the 5% limit, Fisher was forced to admit she actually had the skill. This quirky tea experiment laid the foundation for how we test new medicines, evaluate economic policies, and even how Spotify suggests music to you. It moved science from he said, she said arguments to quantitative evidence.